We're moving to the next section, which is Git, GitLab, and CI/CD pipelines. Another important concept when it comes to Devnet. Because in the development world, software version control is as important as the work itself that you're doing. Right? Keeping track of the work for easy manageability, maintainability is a critical piece. So basically, Git is a software which is used for something called as software version control. Right? You have a software which is being developed. So any code for that matter is considered as code, right? Code or software. The automation scripts that you'll be writing, the Python shell scripts that you might be developing, the configuration files that you'll be developing, or even the network configuration files that you'll be backing up. All these things need to be tracked over a period of time, because as the time progresses, you will lose the information of which copies of files are latest, which files contain which changes. So all this information needs to be kept track of. So the best way to do it is using a very efficient system which will track each and every change that you are making on your system to certain set of files. That efficient software is Git. Right? Incidentally, Git is developed by none other than our good old friend Linus Torvalds, right, who developed Linux operating system. So in fact, the process of developing this Linux, right, what Linus has done is he developed the Linux code, the core of the operating system, kernel. Then he wanted to collaborate with developers over the world to add features to this. So he started collaborating, and then they needed a system to keep track of all the changes that they are making. So he didn't find any of the systems which were existing at that point of time to be sufficient or suiting his needs. So he went ahead and created his own software version control system, which became Git, and he exposed it as open source, just like Linux, and that's how it has become so popular. Okay. Git is a distributed version control system. So when it comes to version control systems, hope that's the point. What is a version control system is ready. Is what exactly is a version control system? I hope that point is clear. Every change that you're making, let's say you're working on a project involves certain Python files, certain Ansible playbooks, certain configuration files, right, which need to be created, modified over a period of time by different developers. Now, different people are making different changes. Very soon things will go out of control. One day one feature is working, the next day the same feature is not working because of the change done by some other developer. So everyone will keep scratching their head like, what is going wrong, why it was working yesterday, why it is not working today. And to roll it back to yesterday's code to make it working, they need to know what are the changes that were done since yesterday to today. And everyone has to roll back their changes, which is a Herculean task. So you need a very efficient system which can keep track of all these changes, right? Who is changing, what they are changing, and in case something goes wrong, we should have a way to go back to a previous snapshot, previous version of the files. So that is one side of the story. The other side of the story is you need a central location where all these files can be backed up safely, and that central location can be shared with different developers all over the world where people can collaborate, right? Be it one organization or it's an open source. If you are using this system in an organization, your organization has geographic locations. So the code which is being developed in one location should be easily shared with other teams at other locations. So you need a central place where this happens. Or if it's an open source project, there also we would like to share our work with the entire world. So we need a central place where we will publish. Others can pick it up from there. So that's the second part of the story. And the second part of the story is GitLab. The first part of the story is Git. Right? So one primary difference is Git is local. Git is local to the system, local to the laptop or the system that you are working on. GitLab is hosted platform, which means it is available on cloud, and that is the central repository location that I was talking about. And GitLab will be coming to that, and we'll be discussing about it. So Git is a distributed version control system. What do you mean by distributed version control system? Is like basically in version control systems we had different types. Like one is local, one is centralized, one is distributed. Local means everything is on your system only. Whatever version controlling is being done, it is being done on your system only. You have a very efficient this thing, but the problem is it is happening on your system only, which means if your laptop crashes, your data with all its version controlling is gone. So that will not scale. Then we have a centralized version control system, which means organization will set up one central server, and all the different teams which are working on different projects, they will push their code onto this central repository. And next day morning, before starting their work, they will pull the code, latest code from that central repository. Now with central version control system, what happens is if I'm working on, let's say 2-3 files, I'll be pulling only those 2-3 files. I'll not have the entire project. I'll just take whatever files which are needed for me, make the changes, unit test them, and then push them back. Okay. So that was what is happening, which obviously has certain disadvantages. If you want to see what is the impact your code is having on some other part of the application, you do not have a way to figure that out. So the next option is distributed version control system, which means the repository or the project is distributed across whoever is working, which means I have entire repository on my system, you have entire repository on your system, someone else has entire repository on his system as well. So the repository is distributed now. The advantage with this is if I have to make any changes and test it, I will know what is the impact my change is going to have on the entire system, because I have the complete project. I'll be able to run the complete project and see the impact of my changes. But then you might say, okay, is it not inefficient? Like everyone is having this entire repository replicated, and when they want to coordinate these changes, the entire repository needs to be pushed back to the central location. Right? That is the case. That is true, but Git is so efficient, it manages this entire operation in such a way, it's so efficiently that we'll never really feel this as an overhead. So in that sense, it is a distributed version control system. Git allows developers to track the changes to their source code. Also allows them to collaborate with others on software development projects. It enables multiple developers to work on the same code base simultaneously. Now, I'm working on one part of the code, you're working on another part of the code. I cannot wait till you complete your changes. You cannot wait till I complete my changes, right? So we both will take the file, start working simultaneously. Now we both need to merge these changes. So we will sit and see are there any overlapping changes. If there are any overlapping changes, we'll discuss with each other and decide, okay, whether my change is latest or your change is latest, which change should be kept, which changes should be thrown away. We'll do all these things and merge our changes, work together and push that file to the repository. And it keeps track of the changes made by each developer and merges their work together. Now, Git works on almost all operating systems, Windows, Mac, Linux. On Linux systems, 99% of the time it is already installed. If not, we can just install it using any of the package managers like your yum, dnf, apt, etc. Okay, so we just if assuming that you're working on a Ubuntu. Okay, these are CWS. First check if it is installed. Now it is the standard command to check if any software is installed, open source software specifically, is git minus minus version. If it's installed, it should show the version, otherwise get an error. It's not installed. This is CWS, so Git is installed anyway. Even if you are using any Linux operating system, 99.9% of the times it will be there. Even if it's not there, we just have to, you can use it, install it using. Update. So we might get a different message if it's not already installed. On Windows, we get something like a desktop. Of course, on Linux also you will have this desktop available, but command line is more. On Windows, when we download this, it comes as an executable, and we get these things. We get a GUI, Git GUI, Git bash, and Git command line. And Git bash is like a mini Linux running on your system. So if you don't have a Linux VM, but let's say you want to practice Linux commands, you can just install Git desktop. You get a mini Linux kind of environment with this. And most of the Linux commands work here. So if you're working on Windows, there's a preferred way to work with it. Otherwise, once you install, it is available from your command prompt as well. This is the bash. Git GUI, I mean, it's just for namesake. It's not that useful. Create new repository, clone an existing repository, or put an existing repository. And so you can give the repository URL. That is the remote repository, and it will open it. Command is like just like your command line. Okay, so coming to installation on Windows, it's a simple, straightforward downloading any executable and installing it. On Linux, 99% will do that. If not, we can use apt. Mac also mostly will do that. If not, we can use whatever that mechanism available on Mac. Okay. Now, starting off things, there are multiple scenarios that can happen. Right? Let's say you are starting a fresh project. You are given a task and then you realize, okay, I'm going to develop some, create some code for this, write some automation scripts, then there'll be some configuration, whatever are the project artifacts, resources. And you decided you need to version control them for your own good as well as for the project's sake. So you're starting afresh, and from the beginning you realize, okay, you need to version control, so you can you are better control of the things. You can start tracking them from the beginning itself, right? Or let's say you started working on a project, and as an afterthought, after some time you decided, okay, now I want to. It would have been better if I had version controlled it. Nevertheless, it's never too late. Let me start using version control. You decided to start tracking from that point onwards. So there's an existing repository which you want Git to track. So first scenario is you're starting new, you want to make use of Git to start tracking your work. Second scenario is you have an existing project, then now you want to start making the changes, start tracking the changes using Git. Okay. We'll be seeing those two scenarios, but irrespective of which scenario it is, what is the main intention of Git is keeping track of all the changes, which means any change that is being made to any file, once Git starts tracking, we should know, right? So for that purpose, we need to configure the settings, right? We need to configure who is using the current user and what's the email. Right? Now this email can be anything. It is just for keeping track, right? Who is making the changes. So ideally in organizations, this will be your official mail ID, so that people, when they pull the repository and look at the history, right, who has made the changes, they'll be able to see the names and email address. So there's a way to communicate with the person who has actually made the changes. Now, if you don't configure this also, there's nothing will happen, but periodically it will keep warning you, periodically it will keep showing you, saying you have not said these things, I'm going with the defaults, etc. But as a best practice, you're supposed to, these are the first things that you're supposed to do. Now here there's something like global, right? Which means, now we said that Git is all about repositories, right? Now, projects, we'll be working on different projects. Each project becomes one repository. So you can make these settings either at that repository level or one common set of settings across all the repositories. And that common set of properties across all the repositories will be marked as global. So first we will see the local side of the things, which means you're working on your laptop. You started working on a new project. You want to start up things. Only the initial how you start up things will be differing between those two scenarios. Now, at any point, if you want to see what is the configuration settings that are there, you can use git config -- list. So it shows what is the username, what is the password. Now these are at the global level because I'm not inside any Git repository. How do I know whether I'm inside a Git repository or not? You do git status. It says if I'm not inside a Git repository, of course, though it's not that fatal, it says not a Git repository. So you know that you are not inside any repository, you are in a fresh folder. There, if the settings are working, which means they must be global. At a global level, this username and password email has been set. Okay. Now you created a project directory. You changed to the project directory. As of now, it is empty. But as you said, as I said, you woke up early. You decided to start tracking things from the beginning itself, which means first you need to tell Git to start tracking this folder. Right? So you do that using Git init, initialize the things. It says it initialized an empty Git repository in this location. Is that location? Wherever I am, the location itself, and .git. Right? So if I do ls, there is no change. But if I do ls minus a, there is a change. A hidden folder has been created. Okay? You might ask me, was this not there from the beginning itself? If we go back, and click other things. There's nothing. So it will get init, it initialized. You do an ls minus a, you will have this. Now, what exactly it has done is it draws you so much, draw becomes draw. Okay, that one command, what it has done is it has created three things. One is your working directory. Second one is local cache or staging area. Third one is local repository. Right? So your working directory was anyway there. When it created the .git folder, these two got created, local cache and local repository. Okay? So your ultimate goal is whatever you are doing in this working directory should keep getting backed up, with version controlling into local repository. And that is our first objective. Now, any changes that you do before pushing into local repository, we don't directly push the things. We go via this staging so that you can have better control in case you decide you make up your mind not to track some things or not to undo some things that you have done, and so you'll have a control. So when you're during the day, when you're doing all your work in this local working directory, after you make the changes, you keep pushing it into local staging. Then at the end of the day, once you push into the local repository, once the files are in the local repository, your life cycle is complete. Right? You create a new file, you push it into staging area. From your staging area, you push it into your local repository. Once it is in this local repository, that is inside this .git folder, if you see, it manages internally multiple files in branches. There's a concept called as branches, then hooks, objects, refs, references. We'll be seeing all this. What is a branch? Okay, so it is these folders which make up your local repository. So it is into these folders that the changes that you are doing in the local folder, which is nothing but this. should be going into. Okay, so we took a blank folder, we initialized it. Now, at any point of time, we will check the status, like what is happening inside my repository using git status. Right? So we'll do git status. Now it says something like I'm on branch master. Now what happens is all your work that you're doing is getting tracked in the form of a tree. In the form of this tree. This we call it as main or master, the main branch. Then let's say we want to work on something else. We create a fork from it. I mean, we create a new replica from it. This becomes like a new branch. Okay, so that is the concept of branches. Branch is nothing but we'll be getting to the details again. Branch is nothing but like a replica of the code that is there. And the code, there's one version of code that is there. Now, normally we do this thing, right? You're working on a document, or you're working on some file, some configuration file or a script. Someone asks you, okay, can you just pause that and then make some other change that and give me? Like now you're scared. You don't want to lose the changes that you are doing already. So what you do, instead of modifying the file itself, you save it, you make a copy of it, right? And you start working in the copy. That's the same concept, right? This is your main branch, which means at any point of time, you should have your stable code here. You want to make any changes, you don't want to mess this up, right? Keep this as it is, create a replica, create a copy, and start playing around with this. So even if something goes wrong, you can just discard this part, right? You still have your original changes intact. That's the concept of branches. Okay. So one scenario that we have seen. The second scenario is cd dot. This is afresh. Now we'll be creating some file here, and then we'll be tracking the checking the life cycle. But suppose there is one more existing, we already have that, right? This we already have, and on test.py. We already have. Okay. Test.py to project. Check its status. This is not a Git repository. Now make it as a Git repo. So this is the second scenario. You already started working on it. You created some files, and then you decided, okay, you want to do version control. And simply come to this directory. This is your working directory, and do git init initialize. Same thing happened. It said initialize an empty Git repository because it has created a local repository, which obviously at the very beginning, it is empty. So I do ls minus a. You have your file as well as this .git directory. You do git status. It says something like, yeah, you asked me to start tracking this folder, and I found that there is one untracked file. Right? You have initialized, you have made this folder as a Git repository, but there's a file which I don't know about because that file was already created before before I was initialized. It was initialized. Right? That's what it is saying. In the other case, there's nothing here. Okay, now you start creating, start your work. So some change has happened. Its status will show you the same. And from now onwards, like both are one and the same. So we have added a file, but we have not told Git to start tracking it. Which means what just happened is you have these three phases: working directory, staging, and local repo. You made some change here by creating a new file. Right? Earlier all three were in sync. This is empty, this is empty, this is empty. So all good. It says nothing for me to, there's nothing that for me to do. But then we disturb the thing by creating one file in the local repository. So immediately your local repository became out of sync with your staging area, the temporary location. Where is that? We cannot see it. It is inside one of those directories, the .git folder. Right? So now this and this are out of sync. So it is saying untracked files. I'm seeing some untracked files, which means this file is there in your local repository, but it is not there in your staging area. And the first comparison is always between the immediate neighbors, between this and this. And comparison will always be between this and this, or this and this, right? Not directly between this and this. So when we said git status, it first detected that there is some change here. It compared whether that change is replicated in local staging area. Since this is empty, it is highlighting the difference, saying there is one untracked file. And it is also giving you hints what you can do. And you can use the command git add the file name. We'll do that. So we'll say git add test.file. Now let's do git status again. It says on a branch master, no commit set, which means I have not pushed anything. Changes to be committed. And now we made some change in the current working directory. We moved that change into staging using the git add command. Now these two are in sync. The working directory and your local staging area are in sync. But this and this are out of sync now. That's what it is saying. Saying changes to be committed. Committing means pushing them into the final repository, local repository. Right? Committing means taking the things in and backing them up in local repository. So that has not happened. Working directory and staging are in sync, but this and this are out of sync. And it is also giving you a hint. Either you can undo the thing, whatever you have done, you can undo it using git remove -- cached file. So if you do that, whatever has been pushed into cache will be taken out from the cache. So we can do that. Git remove rm -- cache. It has been removed from where? From staging. If you git status, we will see the previous status. Now, let's say we are adding them again, but let's say there are a lot of files, where we have made the changes. So instead of going on adding one by one, or specifying multiple file names, right? Say you want to track everything. You simply say git add dot. Now it's ready to be committed. When you are ready to commit, use the command git commit. Now committing is like pushing something into local repository. So whenever you're pushing something into local repository, we said that it's all about tracking, being able to track things, right? So which means you should have a message, a commit message, why this change is being pushed into local repository. So that we call it as commit message. So we use git commit, and that is mandatory. If you cannot check in anything, or you cannot commit anything into local repository without giving a proper commit comment. Right? The proper is like a proper commit comment is a commit message is like a additional enforcement that we can do, but we cannot really check what is the quality of those commit messages, whether they are really useful or aren't simply using them because it is forcing them to. Anyway, we can do this using git commit -m. We give some message. Right now we are adding the files initially. We can say adding new files. Adding where? To the repository. It says yes, one file has been added. Now you do git status. It says I'm on branch master, nothing to be committed, working tree is clean. So that cycle is complete. I created a new file. I pushed it into staging using git add dot or git add file name. From staging, I pushed to the local repository using git commit by giving a commit message. So that is one cycle. Now, tomorrow you come, take this file again, make changes. Again, these three are out of sync. And now this has new changes which are not there. So again, it says something has been modified. Right? Earlier it was saying it's a new file, untracked file. Now it is being tracked, but it is modified. And you need to track this modification. You follow the same process. You say git add test.py to git status. It says it has been modified there in the staging area, but not in the local repo. Git commit -m. Now this is where you are supposed to give proper comments, appropriate comments, not simply okay, change this, change that, change. Why something has been changed? Because that is the useful information. Okay, you feature related code. Then added, committed. Once committed, these files are backed up into the local repository with a unique commit ID. Every commit you make to the local repository is given a unique commit ID. That's what we said when we said that everything is being tracked. Every single change by every single developer is being tracked. So how will you know? Say git log. You see it started showing. First, I right? I gave the comment git message, commit message as adding new files. Now, who has added author date? And these details are coming from the configuration that we have done initially. Right? I mean, I've not shown because it's already been done, but it's there in the reference spec. And then this is that unique tracking ID, kind of tracking ID for the changes that you have done. After this, again, we modified our code. The same process continues. Right? Commit. This is the commit ID. Now, previously this was the latest change. Now this is the latest change. Right? So there is something called as a head, which is like a reference. Right? That is pointing to this commit. The head is pointing to the latest commit. In other words, you can think of this head as the latest commit that you have made, and the head of the hierarchy. So this way it shows this complete. Now in this, let's say if you have lot of log messages, we have things like, okay, show only one, it log one. It log. One thing is we can use minus plus one line. It shows you concise information. You see those long strings have been abbreviated. Only the first seven alphanumeric characters have been considered. Minus one. You do git log minus one, only one message will be shown. Like let's say you have huge log, 10, 15 messages. You can tell, okay, show me only first 5. Here only 2 are there, so only the 2 are coming. Okay, so that is what we do with Git on daily basis. The local files are continuously backed up to your local repository. Suppose I want, I'm now using less that test.py. Both are there. But suppose I want to move back to this code, and this was a commit ID. So what I'll do, I'll say git checkout this minus b. Right? What happened? I moved to this. I moved back in timeline, which means my files have been reset to what their state, what was their state at this point of time. So it is complaining, saying your latest change was here, head. Now you have detached your head. Right? Your head is no more pointing to the latest changes. It is pointing to this thing, which is like, yeah, you can. It gives you sufficient warning, saying you can look around and make any experimental changes, but if you commit them, like you will be in trouble because you have taken an older version of the file and then you are making some changes, which means it might leave your files in an inconsistent state. Right? So what they are suggesting is you create a new branch, right? You create a replica and then move there. So that we can to create a branch. We can it's or if it's a mistake, simply go back. Okay. I switch back. Now I'm again back. Okay, now let's say I want to work on a new feature. As we said, the best practice we said is uh, creating a branch. And we also wanted to move back to this instant and see the changes. And we will do that. Okay. Check out. Yes, we get the same message. We do git switch -c test branch. Okay. What it has done is it took this version of the code and created a new branch and moved to that branch. If I do git branch, there are two branches. One was master where I was initially and created a replica with the older ones and I moved here. Now if I do file is same, but if I do cat, you see only this thing is there. Only my first initial statement is there. The second statement which I added is not there. Because I have moved, my latest changes are here. But I have moved back in time at this point. How do you get your latest changes? Move back to the older one, which is a branch. Git checkout is the command to switch between branches. Git checkout master. I move to master. Now you do the same command, get test.py. You'll see both. On the other branch, which I created based on a previous commit, I have my previous code. On the main branch, which is my latest this thing, I have my latest code. Okay, so that is the version control that is happening. So this is the older branch, which ideally should not be the case because that could be an obsolete version. So ideally, what we do is like we create a branch from the latest this thing. So there are two ways to create a branch. Either we can create a branch which is nothing but to create a replica and then move to that branch, right? Git branch and the branch name. Branch one. It has created a branch. How will you know? Git branch command. Right? There's a new branch which is created, but I'm still in master. Now, what are these branches again? Nothing but replica copies of your files. Nothing but copies of your files. There's one master copy of your file, set of files. Now I created one more. But my current directory is still pointing to, when I do this, it is still pointing to master. Now, how do I switch to this branch which I just created? I have to do git checkout branch one. And now if I do git branch, it shows me I am in this new branch. I do git checkout master again. As I said, there are two ways. The second way of creating a branch is to directly git checkout, and we are moving. Where to move? minus b branch 2. What this command does is it creates a new branch and directly switches to the branch. So if I do git branch, there's a new branch and I'm already on the new branch. What are my files? It's the same because it's the same replica of your files. What are its contents? Whatever was the latest, because I created a replica from my latest version. Now I'll make a change to this. Where I'm making the change, not in the main branch, master branch, but in the sub branch. Nano test.py. I'd say it's defecting branch 2. Again, in this branch is the same story. Okay. Let's see what is happening in ls dot git. Right, we have these branches. Nothing is there. Probably because I have not pushed anything. What is there in refs? Yeah, that here. In refs we have all this. Branch 1, branch 2, master list. So it just keeps track of the changes that I'm making. So I'm on branch 2. I made some changes. So I need to push them to branch 2. Git add dot git commit ISM. Okay. Its status. You're on branch 2, it's all clean. Now these branches are typically, we create them for doing this temporary work, right? So we need to take, we made some change. So we need to test this change. We need to ensure it is working fine. And if it's working fine, we need to give it to customer. And then after everything is done, this change should be preserved, right? Let's say either this change should be preserved, or we can just throw away the change, this change. If it has to be preserved, we need to take this branch and merge it back into main. Right? We had the diagram, branch diagram. Right? We had this main branch running, and then we created a branch and made the change here. Now let's say we want to make this change persistent. We take this branch, merge it back into master branch, right? Which is what we'll do now. So I'm on branch 2. Now merging, how it happens is we go to the parent branch and merge the child branch into parent branch, which means we have to first switch git checkout master, change to master. Right? Now we made the change in branch 2. We say git merge branch. How do you know? Right? ls cat test. Right? I only have these two statements: print hello, print new feature added. But we did something else in branch 2. So now we do git merge branch 2. Merge branch 2. I'm on master. I'm saying merge branch 2. Get the branch 2 changes and merge into. Right? So it shows yes, one change has been done, it has been merged. We'll do cat. The change which we made on branch 2 comes into master branch. We merged branch 2 into this. Now let's say we don't need branch 2 anymore. We can delete it. Hit branch minus d branch 2. Delete it. Okay, so that is how you work with branches, and there's the significance of these branches. Yeah. So we are still on the local side of the things. But as I said, what if your local laptop itself crashes? You have all your version control is being done so nicely, your branches are nicely backed up, merged, etc. etc. But your hard disk itself has crashed. So everything is gone. So one this thing is you need to back it up to some central location. Second thing is you should have the capability to collaborate with other developers. So these two things can be done using one of these hosted platforms like GitHub, GitLab. What are the other options? You have GitHub, and each of these companies, different companies, they have tie-up either with GitLab or with GitHub, or there's one more paid product by a company called as Atlassian, called as Bitbucket. Bitbucket, GitLab, GitHub, these are all remote versions of hosted versions of Git with some UI and some nice features. So if you go to GitLab, you can sign in because it's a cloud-based hosted application. Okay, these are my repositories, projects, and different applications called with different names. GitLab calls them as projects, GitHub calls them as repositories. Atlassian being a paid software, Bitbucket has merged both these concepts, right? You create a repository and inside you can create multiple projects, so that there can be a little bit of confusion if you're going from GitHub or GitLab into Bitbucket, right? There you'll try to build this correlation. Okay, what do you mean by project? What do you mean by repository? Okay, ultimately these are the projects inside which your work will be stored. Now, what we need to do, we have our local work sitting here, and that somehow should be brought here, which means I need a blank project to hold the things. So I'll create a blank project, and we can create a blank project, or these are like you can create it based on certain templates. Right? You can import a project from someone else's account. So we say create a blank project. And we can choose to keep this as either private or public. Now, there's a concept called as like by default a README file can be created. I don't want. I'll go with the defaults other than this. Let's say create project. Now it has created and it has given you some instructions. Right? Go to your command line. Go to command line. Now you need to sync this remote project and your local project. Right? So that's where it is giving all the help. Go to command line and it is saying you can do this configuration because I am making the changes with my account. So it's asking, okay, do this configuration so that we'll know who is making the changes. Then in local, if you want to create a new repository, we follow these things, right? The same similar commands that we have done. Right? We take this current repository, what we have created here, clone it to local. Clone this remote repository into local. And that is if it is new. Then we change to the directory. Then we create a main branch. Then we do our we create a readme, we add that readme, we commit it, we push it back, push. From there, you push it back here. Okay. Add is for adding a file from working directory into staging area. Commit is for taking the file from staging area, pushing it into the local repository. Then push is to take the file which is there in the local repository and push it to remote like GitLab or GitHub. So if we did not have a create directory, we will be following these steps. Since we already have a project directory, we need to follow these steps. Right? So we need to cd to the existing folder. So we go here. We are already here. We are inside this. Then we do git init minus initial branch is equal to name. This also we have seen because the local, this also we have done because the local is already Git repository. Now there is one thing, this guy creates branch name as main, right? We have master there, so that could be a little confusion. So we'll do okay. So we can skip this part because we already have initialized it. Now we need to add this link between remote and local, right? So this is the reference to remote repository. This is the reference to your remote repository. git@gitlab.com/nataja/test. But since this will be like a big name, it will be difficult to refer every time. We give it a short name called as origin, which means the source where it's. So we will take this command and run it. Okay. Now to do git remote. Says yes, origin is that. Git remote -v verbose. It shows more data. Okay. So now it's the same thing, two entries. One is for fetching, which means fetching means take the things from remote to local. Bring the changes from remote to local. Push means take the changes from local to remote. Right? It is for those two operations. Then we have to add our. Right? We already it's already clean git status. Nothing to be added, already there in the local repository. So commit is also we have done. We just have to do git push to git push upstream. Right? Upstream means the remote repository. Origin, set origin, take origin and push it to main. In our case, this is master. I take this. Now, right, it somehow has to connect to your remote, which is your GitLab, which is on cloud, right? From your local system, it has to push the things to internet, which is there on cloud. How did this happen? This happened because of this link, and this link is SSH based. This link is SSH based. That's why you see it did not ask me for username password. It directly pushed the things. So if you go here and refresh, our file is created from local, whatever we had, that file is created. But how did it know? How did it log in? Right? Where did we specify the credentials? We have not done anything. That's because we used SSH mechanism to connect and not HTTP. Though this is on web, we did not go via the HTTP route, which would have asked us to enter the username and password, which I used to log into this. And instead, now HTTP URL looks like this. Right? If I click on clone here, you see there are two options with SSH and or with HTTPS. HTTPS looks like this, HTTPS, GitLab, etc. SSH one looks like this, git@gitlab.com : so it did an SSH to this GitLab instance using the username as git and the system as gitlab.com. Now to be able to do SSH also, we either need username password or we need keys, right? That I had already done it and kept it. Right now that can be seen if you go to this and right, go to home, click on this. This is a profile. Say preferences. Click on preferences. On the preferences, you will see something like SSH keys. Click on this SSH keys. So I had added, right, from my from that system, I had generated SSH keys. I had already added it. Using that, it is able to communicate. If you did not have, then what you have to do is, right, from here you are here ls dot /dot ssh, right, here your SSH keys, and as I said, when we are talking to remote host via SSH, right, you keep the private key with you. Take the public key and put it on the server. Right? Suppose I want to use this id underscore ed25519.pub. I'll copy the contents of this. Then I come here, say add new key, put my new key here. Right? Choose some details, choose an expiration date, and add. Then it becomes like this. The SSH keys that you have already seen. Then, whenever we are pushing from here, your private key is sent along with it, and your passwordless authentication communication happens. Right? By default, okay, there's only master. So it created this, it took this master branch and pushed the files from there. Okay. Now, how do we collaborate? And let's say I'm another developer. Some developer has um, created the file and uploaded. Now this is a repository. I want to share. I take this one of these links, right? Either SSH or HTTPS. Take SSH, go here, cd dot dot. Right? What do we need to do? We need to clone. Cloning means the repository which is there on remote, make a local copy. Git clone URL, repository URL. Right? Again, for this to work, either you should have that username password or um, the keys, SSH keys. Okay, it has cloned. If you do an ls, right, I have this test project, ls test. How come nothing has come? Put a line. Remote head refers to a non-existing ref, unable to check out. Okay, I'll see what is happening. But this is the way you can link your local and remote. Now, whatever is happening here, we can keep pushing to remote. So we'll cover this CI/CD pipelines in the next class. What do we mean by CI/CD pipelines?
Recording stopped.